In this video, we want to start looking at some more complicated antiderivatives. So let's begin with this particular example. And recall that all this notation means is that we want the family of functions whose derivative is exactly this expression. So let me go ahead and put up the answer, and we'll walk through why it's the answer. Right, so the antiderivatives here are going to be 1/9 x cubed plus x raised to the 9th plus c. So why are these the antiderivative of this expression? Well, if you take the derivative of this, right, we bring the power down in front and multiply. Subtract 1 from the power, and then chain on the derivative of the inside, which would be 3x squared plus 1. And the derivative of c is just 0. And so, of course, 1/9 times 1/9 is just 1. So this is going to simplify to exactly the integrand. So what we have here is a situation where the integrand, in order to take the derivative to end up here, we had to use the chain rule. Right? So in this series of videos, we want to look at a process that undoes the chain rule to find antiderivatives. Okay? And the process is called substitution. If we look at this integrand, this piece here looks like the derivative of x cubed plus x. In fact, it's exactly the derivative of x cubed plus x. So what we're going to do is we're going to substitute for x cubed plus x. And then the 3x squared plus 1, well, that's exactly the derivative of this. And the derivative of this is actually going to show us the relationship between the differential in u and the differential in x. Okay. So du and dx are going to be related by this equation, since u and x are related by this equation. Okay. So the next step is just to completely rewrite this integral in terms of u. Well, 3x squared plus 1 dx is exactly du, and x squared plus x is my u. So my new integral is just u to the 8th du. And notice what we've done. We've taken a somewhat complicated world involving x, and we switched to a world in u's that is much easier to integrate. Right? This is just u to the 8th, and to find the antiderivatives with respect to u, we're just going to add 1 to the power and divide by the new power. Okay? But ultimately, we wanted antiderivatives in terms of x. So to find those antiderivatives, I simply substitute x cubed plus x back in for my u. And so we have arrived at the answer that we started with. Okay? So over the next series of videos, we're going to look at a number of examples involving u substitution. Some are somewhat straightforward, others will be a little bit more complicated.